All right, so let's get going on today's class. So what we're going to do today is we're going to begin our look at Chapter 2, and we're going to stay here for a while because Chapter 2 has three very important concepts that we're going to need to know moving forward, and that is measurements of central tendency, like the mean, measurements of variability, like standard deviations, and then a very important concept is z-scores, which is ways of standardizing scores so that they can be compared to each other. But we're going to start off with our look at, here we go, the mean. And this is, once again, descriptive statistics. And once again, this kind of follows the pattern of doing something that's very basic, something that's not going to look like statistical analysis in psychology, but something that we need to address and we need to become very, very familiar with, because it will be used, these fundamental skills will be used once we start doing the actual analyses of issues in psychology. However, we got to put into practice before we get there, so without further ado, let's take a look at measures of central tendency. So let's set this up with an example. Let's say that you graduate from IUSB and you pursue your career and you become an educational psychologist. And let's say that one day you're contacted by the Indiana state government, and the governor asks you to give him some information. He needs some information. Specifically, he's working on the budget. He's working on the state budget, and he wants to make sure that he has enough money put aside to fund higher education. So that's his goal, that's his plan. He wants to make sure that students have enough money, enough funding in order to go to university, in order to go to college. So what he wants from you, being an educational psychologist, is he wants to know how much money does the typical student have right now. So in the current situation, in our current state, how much money does the typical student have? So how much do they have from scholarships? How much do they have from their parents? How much do they have from part-time or full-time jobs? How much do they have from any source, scholarships, funding from the university? How much do they have to go to university from any source? That's what he wants. And as an educational psychologist, you might have that data. And you actually might have tens of thousands of interviews, tens of thousands of survey answers given out. You might have been asking this of students for a while, and you have an entire list of data. You have an entire list of scores. That's great for you, and that's great for doing statistics, but that's not going to make sense to a particular individual. So if you start telling the governor that, well, this one student that I interviewed, they have $12,000 a year. This other student only has $8,000 a year. This other student only has $2,000 a year. This other student actually has a full-time job. They got $40,000 a year. And you go through the entire set of data, this individual is not going to know what to do with all that data. They're not going to have a clear picture of how much does the typical student have. What you need to do is you need to take that information that you have and boil it down to one number, one score, $1 amount that you can tell this individual that is representative of the entire list of scores that you have. So that's what we're going to concentrate on today in this first part. How do you find that one number? And how do you make sure that that one number really is representative and is not misleading when you report it as standing in for your entire data set? So that's the idea of central tendency. So we're going to talk a little bit more about the idea of a representative single score. We're going to then introduce three measures of central tendency: the mean, the median, and the mode. And these are the ones that are by far used the most in psychology. We'll then mention how to calculate those three, kind of give you an inside view of what's going on. In the second part of today's class, we're actually going to use Excel to calculate those. And then we'll talk about important characteristics of the mean, the median, and the mode. There's three of them. They're good in some situations, not so good in other situations. That's why the three of them exist. And that's part of our jobs as psychologists and statisticians to determine for any particular situation which one of those three would give the best representative score. All right, so representative single score. This is also known as a measure of central tendency. This is one score, one number that defines the center of a distribution. So we were talking about frequency distributions yesterday. This is one number that can stand in for that entire graph. This is one number that can stand in for that entire table. And it's one number that is typical of all of your scores, or representative of all of your scores, or can stand in for all of your scores. So a nice analogy for this is, let's say that today aliens landed on Earth from outer space, right? So we had alien visitors for the first time in our world's history, maybe. And they came up and they saw just this vast diversity of humanity. And it was too much for them to take in. So they come to you and they say, look, we want to know more about humans. What's your typical human like? Introduce us to your average human, your typical human. Well, you have a choice to make. And you want to make one where it's a truthful kind of representation of what humanity is like. So people that you wouldn't pick would be somebody like Neil deGrasse Tyson, right? That would give them a vastly overestimated view of how intelligent humanity is. I mean, he's one of the leading scientists in the world, not typical of the rest of us. You would not want to choose Simone Biles. Too powerful, too flexible, too agile. Would give them the wrong impression of what, people are like. You would not want to choose Hafthor Bjornsson. He's too big, he's too strong. He's not representative. This is not what most of us are like. What you would want to choose is you want to choose somebody like Luke Wilson's character from Idiocracy. So for those of you that might not be familiar with this movie, this is a movie where he gets frozen as part of a military experiment. He wakes up decades later in an America that is actually kind of coming, this is kind of becoming true, less science fiction, more science fact these days. But in the story, he was chosen because out of everybody that they tested, he was the single most average person. So he was of average height, he was of average weight, average intelligence, average emotional maturity, average artistic ability, average running speed. He was literally at the center of just about every measure that they had. And this is the kind of person that you would want to introduce the aliens to. You would want to introduce them to this individual because that would not overestimate our abilities. It wouldn't underestimate our abilities. It would give them a kind of typical idea of, all right, this is your average human being. This is what human beings kind of typically are. All right, so that's the idea of that single representative score. So what we're going to find out to do is how to do it for number scores rather than human beings, how to calculate this so that we're not, again, being biased in terms of picking a score using our own human minds and our own human biases. We remove that bias by taking a procedure that is objective. So what do? Well, we're looking for that central tendency. And let's say that this is the frequency distribution that we're looking for that most representative score for. So this is hypothetical data, but we'll tie this back into that educational psychology example. Let's say that this is your frequency distribution for how much funding students going to university in Indiana have access to. So you can see, just as an aside, we're building on exactly what we learned last time. So last time we learned about frequency distributions. These are the possible amounts of funding, and then the height of the line represents the frequency with which students receive that funding, like how many students get each level of this funding. So this is going to help us understand, measure the central tendency. And as you can see, this frequency distribution indicates that there are very few, if none, no students that receive absolutely nothing, right? They don't have a job, they don't have parents to help them out, they can't get a loan from the bank, they can't get funding from the school. There's virtually nobody that has $0 in order to go to university. And then as it increases and increases and increases, we get to 10,000 here, we get to 15,000. Again, this is hypothetical data. And this is where most students are, so they'll get help from their parents, they'll get scholarship, they'll get financial aid, they'll have a part-time job, they'll have that amount of funding. And then as the funding increases, once again, the frequency with which students have access decreases. So these would be people here on full scholarships. And then this little hump over here, This would be individuals with full-time jobs going to university part-time. And then we get to the independently wealthy trust fund individuals. And again, that goes lower and lower and lower as you get higher and higher in terms of funding. So that's our frequency distribution. And again, this is thousands of scores. And when you report thousands of scores, it's very difficult for a human mind to understand that. So how can we understand these thousands of scores? We boil it down to one score that stands in for the entire distribution. So let's take a look at the first one here. This is the mean. So the mean is the number that you've probably been computing as a measure of central tendency for a while now. It's also known as the average. And you get this by just adding all your numbers that you have, adding all your scores, summing your scores, and then you just divide by the number of scores that you have. So if somebody was to ask you, oh, what's your average grade in university? You would add up all your grades, divide by the number of courses you've taken, and there's your average grade. In this frequency distribution, the mean is that score right there. So for our distribution, the mean is just under $20,000 of funding per year. So that mean is actually the balance point of all the scores. So the mean is that point, that one score, where if you were to carve this out of wood and you were to place it right on that point, it would balance. The two sides would balance. So the mean kind of takes into account the weight on one side and the weight on the other side, and it also takes into account the distance from one side and the distance on the other side. So if it was a scale, the mean is where the scale would be balanced. For a sample, the symbol for a mean is capital M. So again, read this as sample mean. For a population, the symbol for a mean is mu. Again, read that as population mean. And this is foreshadowing a couple of things. And whenever you see a symbol, that is a very important indication that the concept that you're learning is widely used and highly important. So for example, means are by far the measures of central tendency that are the most used in psychology. They are so used that these statisticians who used to have to write all of this stuff out by hand got so tired of writing out those four letters, M-E-A-N, they started getting carpal tunnel syndrome that they said, you know what, let's just call it M. We'll just call our sample means M, right? We'll cut down our work by 75%. So that's the first thing to realize. Anytime you see a symbol, highly important concept, so make sure that you pay attention to it. And then the second thing, you'll see that we have the mean for a sample and we have the mean for a population. A population is everybody. Population, in this case, would be the scores of every student going to university in Indiana. A sample is the score of just a subset of those. So you guys are a sample of the Indiana University student population. So we'll get more into that as we go along, but I just want to point out that there is a distinction between those two, and those two symbols are different because the difference between a sample and a population will become more important as we move along. So if you see a concept that has a symbol and has a different symbol for samples and populations, just know that you're dealing with a very, very important concept. All right, so that's the mean, balance point for all scores. By far the measure of central tendency that is used most in psychology. So what comes in second place? Second place is the median. The median is the score that just divides the distribution in half. So it doesn't balance the distribution. It takes a look at that distribution and it cuts it in half so that you have the same number of scores on the right side. I do that, yeah. Same number of scores on the right side as you have on the left side. So it just cares about the number of scores on one side of the median and the number of scores on the other side. It's the score that cuts that in half so that you got the same number on both sides. So the median I mentioned is used less than the mean, and this is reflected in the fact that the term for the median is just median. So sample median is referred to as median, And population median is referred to as median. So you can see that drop in importance. Not only does median not get a symbol, but we're really not worried about sample versus population medians either. So median is an important central tendency for psychology, but it does come in second place. So what comes in third? Third place is the mode. So the mode is simply the score that has the greatest frequency. It's the score that has the highest frequency. It's the score, it's the measure of central tendency that's actually the easiest to see on any frequency distribution graph because it's the score that is associated with the highest peak. So, excuse me, so in this case, the mode here you can see is about $15,000 of funding. So the mode again is just that highest, it's just the score that has the highest frequency. It's the score at the peak of your frequency distribution curve. Once again, for a sample, the term for mode is mode. And for a population, the term for mode is mode. So once again, reflecting that idea that it's not as widely used as the mean. All right, so any questions so far on those three measures of central tendency? All right. So how do we calculate the mean? So we'll see how to do this in Excel in the second part of today's class. But we'll go through the kind of idea of how you calculate them. So for the mean, you calculate that by adding up all your scores, and you divide by the number of your scores. So for a sample, the sample mean equals the sum of your scores divided by the number of scores. So that small n is the number of scores for a sample. And once again, just a reminder, do not read this as m equals sigma x divided by n, because to our human brains, m equals sigma x divided by n is meaningless. But if you get into the habit, if you practice, if you repetitively go and wax on, wax off, and say to yourself, oh, sample mean equals the sum of the scores divided by the number of the scores, that's going to get ingrained in your head, and you'll never forget what any of these functions mean. All right, so that's for a sample. For a population, same exact formula, just with the population terms in it. So for a population, the mean of your population equals the sum of your scores divided by the size of your population, sum of your scores divided by the number of scores that you have. All right, so that's the mean. We've been doing this probably since high school. So let's get on to maybe something that's new. So for the median, calculating the median, all you need to do is you need to find that score that is halfway in the distribution. That score where half of the scores are less, half of the scores are greater than. So for a sample, if you had, for example, 5 scores, you have an odd number of scores. In this case, what you would do, or the idea behind the median, is you order those scores. So you put them in numerical order, and then you simply find the middle score. So the middle score is going to be, there's a formula for it. It's going to be the size of your sample plus 1 divided by 2. So if you got 5 scores, size of your sample is 5, 5 plus 1 is 6, 6 divided by 2 is 3. So your score is going to be the third score in your distribution. That's your median. When your number of scores is odd, your median actually exists in your distribution. So for that score of 5, we got half of the scores are less than 5, half of the scores are greater than 5. That's your median score. If you got a population and the size of your population is odd, once again, you would order the scores, and once again, you would find that middle score, that n plus 1 divided by 2 score, size of your sample, size of your population plus 1 divided by 2. That's going to be the score that is your median. Half of the score is bigger than that, half of the score is smaller. All right, so that's when your sample or population has an odd number of scores. If it's got an even number of scores, you just got to do one slight little change to this. If it's got an even number of scores, then once again, what you would do is you would order the scores, but this time we don't have a middle score that actually exists. So what we do is we take the average of the size of your sample divided by 2 score and the size of your sample plus 2 divided by 2 scores. So in this case, we got 4. 4 divided by 2 is 2, so score number 2. And then 4 scores plus 2 is 6 divided by 2 is 3, so we take our third score. So this is just a mathematical way of saying you take the first score to the left of the middle, you take the first score to the right of the middle, you take the average of those two, and then that is your median score. So that's when the size of your sample is even. And the same thing for a population. When the size of your sample is even, you take, once again, find that middle, take the score that is to the left of the middle, take the score that's to the right of the middle, average those two, and that is your median for a population. All right, the last one, calculating the mode. So for a sample, when you calculate the mode, you simply find the score that has the greatest frequency in that distribution. So the score was the largest, with the largest F, with the largest frequency. So if you have a frequency distribution graph, it's the score that's associated with the peak. If you got a frequency distribution table, you just scan down that frequency column until you find the largest frequency, and then whatever score is associated with that, that's your mode. And the same thing for a population. It's simply the score that occurs the most often in that population. All right, so that's the basics of how to calculate it. Again, we'll find out how to do that in Excel to get the actual numbers. But are there any questions on the background, the concepts of what we're taking a look at? All right, so back to the governor of Indiana. So the question now is, which one of these do you report to the governor of Indiana? Which one of these do you use? Do you use the mean? Do you use the median? Do you use the mode? And as we're going to see, this changes depending upon the frequency distribution that you have. So what we're going to take a look at now is what happens when you get a little bit of weirdness, when you get scores that are outliers, that are very, very large, for example. What does that do to your choice of a measure of central tendency? So let's say that there was a high school in Indiana, and Elon Musk came and visited that high school. And he was just so impressed with the students at that high school that he said, when you guys graduate, all St. Joseph County graduates, right? So when this one high school graduates their classes, he said that every single graduate, every single high school student in St. Joseph County is going to get $60,000 a year college scholarship. So he is throwing his money around and he is saying, you know what, when you guys graduate, everybody, all the graduates in St. Joseph County are going to get $60,000 a year to finish university. So let's say that they graduated this year, right? So they are getting $60,000 per year for their college funding. What does this do to your measures of central tendency? Well, let's take a look. So here we have the mean. And in this case, the mean was just under 20 grand. And as you can see, just visually, it seems to be rather representative of what's going on in the entire distribution. It seems to be a typical amount, a fair amount. There's some amounts that are larger, there's some amounts that are smaller, but it seems to give you a good idea of just how much your typical student is receiving in funding. However, what happens when we have Elon Musk's highly funded students added to this? Well, they're all the way over here. And there they are right there. So not a ton of students, right? Not a ton of individuals, but notice that they are getting massively funded. They're all the way over here. And just like if you were carrying weights on both hands, and then somebody put a weight all the way over here, you'd be unbalanced. And you would have to slide over here in order to rebalance yourself. Well, so does the mean. So in this case, the mean slides over here in order to rebalance it. And this is the mean for this distribution, including these highly funded students over here. But notice now, this number gives you a very poor representative score of how much each student is getting in Indiana University. This number right here now is just under 30,000. And if you report this to the governor, they might say to themselves, oh, well, I didn't know the typical student made that much. That's a lot of money. They don't need any more funding. when in reality, most students over here are way underfunded, way less than the mean here. And the mean here has moved because it is what is known as sensitive to outliers. You get those few students over here that are highly funded, and all of a sudden they pull your mean very, very far in one direction. So if you were that educational psychologist that was analyzing your data, number one, you would want to take a look at your frequency distribution. Number two, if you saw this situation where there's very high outliers, the mean becomes inappropriate to report. The mean is now no longer the typical score for students, because it vastly overestimates how much most of the students are actually getting. So in this case, what could you do? Well, one thing you could do is you can take a look at the median instead. So the median here, once again, all the median wants to do is it wants to look to the left, it wants to look to the right and see the same number of scores. The median does not care how big the scores are. It just wants the numbers on one side and the other side, the frequencies on one side and the other side to be equal. So this would be the median for our pre-Elon Musk highly funded students distribution. So once again, we can see it's right about there at 15,000. And again, that would be typical for this particular distribution. And now what happens when we introduce Elon Musk's highly funded students? Well, they're way over here, right? They're super funded. However, there's not a lot of them, right? So even though they're getting a lot of money, a lot of funding, there's not a lot of them. And the median does not care the size of the amount. It just cares how many people, how many scores are on that other side. So all the median would have to do is move just a little bit, so that now with these newly introduced scores, this number here is now the same as this number on this side. So the median is what's called robust to outliers. It does not move when you add in a lot of outliers, and it's typically used very often when there are very high numbers in a distribution. So for example, if you're calculating the cost of houses in a neighborhood, you don't want one mansion to increase the value of all the houses, so you might report the median. If you're looking at the salaries of employees at a company, you don't want a few CEOs to make it seem like everybody's making a lot of money. You might choose the median in that case as well. So the median right here would not move very much, just moves a little bit. And in this case, that would be a better score for this, because we can't ignore these students. We can't say, oh, let's not count them. They don't count. They're part of our data. They're part of the population. We got to take them into account, but we can use the median to give a more representative score of everybody in this distribution. All right, and lastly, we got the mode, the most fashionable, the most popular highest frequency score. So in this case, the mode would be just under 14,000. What happens when we get Elon Musk's highly funded students added to that? Well, in this case, the mode is even more robust than the median. It does not move at all. It doesn't move at all because it is still the highest frequency highest frequency score. So you could put students at 60,000, 70,000, 80,000. You could give students $1 million a year, as long as the number of students receiving that amount does not climb higher than the number of students receiving this amount. Your mode's not going to change at all. So this would be another possibility to report this data. You might report the mode in this particular instance, just the highest frequency score, the score that most students in this case are receiving, the amount of funding that most students actually receive. All right, so let's take a look at another example. Let's say that Elon Musk, instead of that highly funded $60,000 a year, let's say that he thinks to himself and he says, you know what, that's a bad idea. Why overfund a small amount of individuals when I can adequately fund a larger amount of individuals? So let's say that he still wants to have that commitment and he says, when these high school seniors graduate, not just St. Joseph County, but all Indiana graduates, everybody in the state is going to get funding, and they are going to get a $40,000 a year scholarship. So not $60,000, bringing it back to $40,000, but now funding way more students, way more individuals. What is this going to do to our measures of central tendency? Well, once again, we have our mean right there for our pre-funded, pre-Elon Musk funding here. And what happens when we add this new amount of funding? So they're not over here anymore at 60,000, but now it's all the graduates in Indiana. So it is a much higher frequency, much bigger number of students are getting funding. They're getting less, but there's a whole lot more of them. And what this is going to do is, once again, the mean, which was balanced over here, has a new weight introduced. So the mean's got to move. It's got to rebalance the scales. And as you can see, it actually moves to the score that has the least number of students, right? The least number of students are getting approximately 25,000 a year. So this overestimates the vast majority of students, underestimates just about everybody else. It's actually one of the least typical scores in this distribution, but it is the mean. And once again, the mean is very sensitive to outliers. Going back to the median, once again, highly funded median right there. We add in Elon Musk's hyper-funded students. And now, because of the number of students that are getting this increase in funding, the median is also going to move more than it did last time. So the median is still going to move, not as much as the mean, but it still moves more than last time because now we have more students on this side. So once again, to make sure that the same number of students are on this side of the median as are on this side of the median have to move from here and have to move over to this new position. Once again, notice it does not move as much as the mean. And in this case, you might be wise to choose the median to report the amount of funding that a typical student receives. All right, and then one last example. We'll go to the mode. So once again, there's your mode. Pre-highly funded students, add those hyper-funded students, and what happens? Well, in this case, the mode does not move at all because, once again, not enough students received this amount of funding. It came close this time. Notice that the peak here is almost at the peak there. And if 50% more students graduated, then this would be the new mode. But for the current distribution, the mode is still the highest, is always going to be the highest frequency score, and that score is still the highest frequency score, has not been overtaken by the hyper-funded Elon Musk graduates. All right, so any questions about the mean, the median, and the mode? All right, so one thing that we'll do before we wrap up this first hour here is we're gonna take a look at a real life example. So this is all hypothetical data here, just kind of illustrate the point. But we'll take a look at some real life examples of where a knowledge of the mean and the median and the mode can come in handy to understand kind of issues that are occurring in our society. So one place where knowing about the mean and the median actually comes in very handy is in understanding the wage gap. So you will see contradictory evidence for the wage gap over and over and over again. So for example, here we have the weekly earnings for women with or without children. So we got two sets of graphs. We got women with no children, women with children, men with no children, men with children. So we're going to focus on the no children scores. And you can see that in this case, and this was 2016, the measure of central tendency, the typical amount of weekly earnings for women with no children was $746. The typical earnings of men with no children was $861. So we have women earning less than men. Women with no children earning less than men with no children. We have ourselves a wage gap. That is from one set of studies. That was the Bureau of Labor Statistics earnings in 2016. Here's another set of studies. This one is from the U.S. Census Bureau survey of income and program participation. This was 2001. Once again, earnings of never married men and women who have never had children. In this case, they also included are college educated and work full time. So these are women and men, again, who have never had children. But look, in this case, we got women out-earning men. So now we have a gender pay gap, but it's in the opposite direction. For some reason, males are getting paid less than women for this particular survey. So there's a couple of possibilities here. One could be that this was in 2004. This is in 2016, but I find it hard to believe that the pay for males and women has reversed in just those 12 years. This is college educated. This did not mention whether it was college educated. So that's a possibility as well. But it seems to me that there's two different stories here. One, that women are earning less than males, women with no children and men with no children. And two, that women are actually out-earning males when you take a look at women or males with no children. So does anybody have an idea of what might be going on here? What might be the situation? Any speculation on measures of central tendency? Mm-hmm.
Are they using different measures of central tendency?
Yeah, that's exactly what it is. So it is very likely that these two stories here, they're not fabricated, they're not made up, they're not, basically they're not being untruthful. What it is that these two most likely are using different measures of central tendency. So for example, this measure here might be using the mean. And in the mean, you have a lot of sensitivity to outliers. So this increase here between men and women might be due to the highest earning members of our society, the people that are in the positions of authority, the managers, the supervisors, the CEOs, where women have been shown in those leadership positions to be underrepresented. This might be due to the fact that they're using the mean to calculate earnings for this particular survey. On the other hand, for this survey, they might be using something else, like the median. So we get two completely different results, neither of them lying, right? Neither of them being fabricated. Nobody's making up these salaries. But we get two completely different stories depending upon whether you use the mean or whether you use the median. So it's important to understand these measures of central tendency. Even if you never do a psychology experiment or analyze psychological data, just in your day-to-day world, it's very easy to kind of go one way or the other depending upon which you report. So if you're trying to critically think about the information that you are taking in, ask yourself, one thing to ask yourself is, how did they get these typical scores? Because the story can change completely if you're using one measure of central tendency versus using another measure of central tendency. All right, so that's what I wanted to cover for this first hour. So just a couple, actually just the one announcement. So the MyStat Lab mastery points, make sure that you're working towards those. So you have your pre-test number 2 completed. Remember that whatever grade you got on pre-test number 2, if you want to increase it, I will take the maximum of your pre-test number 2 and your mastery points score. So just to be clear, just to be sure that everybody is aware of how to do this, it's the Quiz Me option in the study plan. You have practice problems and then you have the Quiz Me options. The Quiz Me is where you can earn those mastery points. I loaded a tutorial in the Canvas announcements. So if you're wondering on how to kind of navigate the study plan, I highly recommend take a look at that tutorial and just make sure that you are aware that you don't miss out on any points that you could be earning. And also, if you do get 100% on your pre-test, and you do have some, time to practice, I would highly recommend go to the study plan as well to kind of see what you can kind of get more familiarity with, get more facility with. All right, so that's all that I wanted to cover for this first portion. We don't have a ton of stuff to practice, so we'll take a 10-minute break, and then we'll come back to class. So it is 9:41 right now. So let's get back here at 9:51, and we will start up on the Excel portion of this calculating the mean and the median and the mode.